Hey folks, so as requested, I'm going through the example from last night where we talked about using the normal distribution to find areas between certain values. So we're going to go through that. First, I'm going to take the example we did last night, and then we're going to go through a second example as well. So a couple quick reminders. We had a normal distribution, and to do this, we're going to be using the empirical rule, so it has to be a normal distribution. Some of you who've had advanced statistics classes in the past might have done this using z-scores in the tables or Excel's norm dist command or 1 minus norm dist command. If you don't know what that is, don't worry, we're going to get to that in about 2 weeks, but this is just a way to ease us into it. So we have a normal distribution. I've got a mean of 100 and a standard deviation sigma of 10. Remember, our empirical rule says in a normal distribution, about 68% of scores fall within 1 standard deviation of the mean, 95% within 2, 99.7% within 3, and again, that's only for normal distributions. That's important. So the example we used in class last night, I wanted to know in this normal distribution, what percent of scores would fall between 80 and 90. And to figure this out, again, because it's a normal distribution and I picked numbers that are exactly at units of standard deviations away, we can go and figure this out. So the first step, which we kind of sped through last night, is let's think about how many standard deviations above or below the mean 80 and 90 are. So 90 is going to be, if I look at it, I'm 10 units below. So I could take 90 minus 100 to get negative 10. And divide by the standard deviation. So that tells me 90 is 1 standard deviation below. So 90 is 1 standard deviation below, and I can do the same for 80. 80 is 20 units below because that's 80 minus 100 is minus 20. I divide by the standard deviation, which is 10, so minus 20 divided by 10 is negative 2, or 2 standard deviations below. So now that I've figured out how many standard deviations below the mean 90 and 80 are, then I can use my empirical rule over here to figure out what area would be between those two. So let's go ahead and think about my graphs. So here's my rough normal distribution. So with the normal distribution, let's say my mean is right here in the middle. Now, I didn't put 100 there, I just put the mean because that's all I'm worried about is I'm thinking about it in standard deviations right now. It's a normal distribution, that's all I need to know. So let's go ahead and think, I'm going to use blue for 1 standard deviation. So here is minus 1 standard deviation, here's plus 1 standard deviation. Now that minus 1 standard deviation we just calculated corresponds to my score of 90. 90 was 10 units or 1 standard deviation below the mean. So here's what I've got here. Empirical rule tells me this area right here, that area is 68% between 1 standard deviation below, 1 standard deviation above. I know I have 100% of the area under the curve, and so to find the unshaded area right now, this is going to be 100% minus 68%. So that gives me 32% left over, but that includes both shaded areas. And so I have to divide that by 2. And so I would have 16% in each of the areas. I'm going to shade those in yellow. So as I look at this, I can double check. My area under the curve has to add up exactly to 100%. So 16% plus 68% plus 16% equals exactly 100%. So that gives me my area under the curve. So looking at this, I know 16% of all scores fall below a score that's 1 standard deviations below or 90. And I got this from the empirical rule. So I'm going to use the same graph because hopefully that'll make it a little more clear than last night. I'm just going to switch colors to, I'll switch colors to red right now. And so now we're thinking about a score of 80, which is 2 standard deviations below. So using the empirical rule, I know 95% of scores fall within 2 standard deviations above or below the mean. So over here, this is the line for 2 standard deviations below, which we know corresponds to a raw score of 80 from the bit we did before. And up here would be 2 standard deviations above. So now when I'm thinking about this area, between these, all of this area has to be exactly 95% based on the empirical rule. Now, just like we did up here, if I know 95% is inside those two lines, then it's going to be 100, sorry about that, 100 minus 95, or 5% left, which is going to be split into two tails, so 2.5% in each of these areas. So right here, this is going to be 2.5. I'm not shading these this time. This will be 2.5%. Okay, so now we have it all on one graph. I know 2.5% fall below a score of 80, or 2 standard deviations below the mean. Again, I have that from the empirical rule. So let's think about the area I need to find here. So the area I'm interested in, I'm going to shade hash marks with black. This is the area I want. I want not the whole 16% that's to the left of the score of 90 or 1 standard deviation below, because I'm not concerned about this little 2.5% right here. I just need that part that's in between. So I'm going to take 16% minus 2.5% to get my answer. And that's how we got 13.5% last night. So let's just double check. If this is 13.5, 2.5 plus 13.5 plus 68, because that blue area is all included, plus 16 plus 2.5, if I add up all those numbers, those are exactly equal to 100%. So that's how I can use the area under the curve. Let's go ahead and do one more example. So once again, we're going to have a normal distribution. I'm going to have a mean of 30 this time and a standard deviation of 5. So let's try to figure out what percent of scores fall between 30 and 40. So to start this, again, I'm going to say how many standard deviations above or below the mean is 30. 30 is exactly at the mean, so it's 0 standard deviations above or below the mean. So right here, here is my mu, and that's 30, and that's 0 standard deviations. So what I know about shapes of distributions is I've got 50% on the left and 50% on the right. So I know 50% of all scores fall above 30. So far, so good. That was easy. I know. Let's just go ahead and shade it. Let's shade it in a yellow again. That's going to be my area equal to 50%. So now let's think about how many standard deviations above or below a score of 40 is. So 40 minus 30 is 10, and then I'll divide by sigma of 5 and get me 2 standard deviations above the mean. So if right about here is 1 standard deviation above or below, and over here would be 2 standard deviations above or below, well, again, from my empirical rule, I know 95% of my scores are going to fall within these. All right, this is just like we did before. And so I'm not going to go through the calculations because we did them on the last example. If 95% is between, then I know I have 2.5% in this tail and 2.5% in this tail. Now, I already knew that this yellow shaded area, all of the yellow shaded area, was 50%. Okay, I had that over here. So if I want to know what percent of scores fall between 30 and 40, I can think about, I'm not interested in this area right here, which I know is 2.5%. So I want, of this 50%, I want all but this 2.5%. So I'm going to take 50% minus 2.5%, and that'll give me 47.5%. Sorry, let me fix that. So if this yellow shaded area is 47.5, 2.5% plus 47.5, I'm not going to use this 95% to add up and double check because I've already divided part of it. So then I could just add everything on the left is 50%. 50 plus 47.5 plus 2.5% adds up to 100, so I can check my work. And so my answer for this one would be 47.5% fall between a score of 30 and 40. So as you're doing these, remember if you're adding and subtracting your area into the curve, you always have to end up with an area between 0 and 100%. If you end up with a negative number, if you add up with something over 100%, you know you've messed up your math. And for any of these questions, it's crucial that you make sure that the question specifies it's a normal distribution. You can't use the empirical rule unless it's a normal distribution. Hope that one helped. I'll do a couple other videos for you to help you get ready for the exams.